Greetings, the Austereo 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Today, I'm looking at this Austereo Elektor magazine preamp from 1975, where I've actually redrawn the schematic on paper here, not really for clarity or anything, but mainly so I could put voltage measurements around the circuit, which would be handy if the circuit failed, so we could actually measure voltages to see what was wildly different and replace the faulty component, but also to add in some modifications here and there, so you know it's clear that way. But today what I want to do is I want to fix the issue with this balance pot in their original configuration not working. So in the previous video there were a couple of comments on it saying about this particular trim pot here. It should be a 1K as it is in the original circuit, which I didn't have at the time. It was a 500 ohm, which may or may not affect the operation of this balance pot configuration. So I've actually gone out and got a 1K multi-term pot to put in its place. Okay. And also the other comment was that the pot should not be 100K. Well, yeah, I know that. It should have been more like 10K. And that was the reason when I had it in a different position in the circuit, like off the volume control up here, it was attenuating right down at the very extreme end of the pot, is because the resistance is too high. Yes, I understand that. I've also now got a various bunch of values of pots here for this. I've got a 1K, a 5K, and a 10K right there, so I can do some tests, and they're all in here. Now, another comment was that this trim pot should actually be removed out of the circuit if you're going to use the balance pot there. And I tend to think that that is more correct, because let's think about this logically. When we have this trim pot in circuit and then we introduce this series resistor and this 10K potentiometer across this as well, we're effectively now putting this in parallel with that. And what do resistors do in parallel? Well, they divide, and the resultant resistance will always be lower or at the same value as the lowest resistance in the circuit. So take for example this 1K pot was set to say 220 ohm, alright? Well, the effective resistance with this pot and the series resistor now in parallel with it will be no higher than 220 ohm. And the variance of the resistance of this pot would probably be very, very small, like no more than about 100 ohms or something, which is not going to have an overall great effect on the circuit providing balance. So what I'm going to do is I'm going to test the circuit with the new 1K installed with the pot across the trim pot at a 10K linear here, and you know, see what happens, and then test various different values of the pot, 5K, 1K, etc., and see if that makes any difference. Then I'll remove the trim pot and see what difference that makes. All I can say is that removing that trim pot now would result in you would not have this circuit set to the input sensitivity you want to get the 2 volt RMS out, and it's now reliant on the position of this balance pot. And speaking of this pot, it works in the reverse direction like a normal LPAD attenuator balance pot works. That is, when you bring the wiper to ground at one end of this pot, well, this will then bring this capacitor up here to ground, which will increase the gain rather than attenuate the gain. So increasing the resistance between the wiper and ground, so say it was all the way clockwise in this scenario, because clockwise is down here, then you'd have 10k between the wiper and this end of the pot. Therefore you'd have a fairly high resistance between here and ground, therefore lowering the gain of the preamp circuit. So whether that's acceptable operation or not, I don't know. If that fails, then I'll go back to my original idea of putting in a series resistor here, a 1k, and the balance pot in the traditional L-pad configuration with the center going to ground or the wiper going to ground, and using that to attenuate the balance as you would traditionally in any other amplifier. The other mistake that I made in the previous video is the wiring of this treble pot. On the breadboard, for some reason, I had inversed the wiper and one of these ends of the resistor round. So the wiper, I think it was on the counterclockwise position. So the wiper was actually over here and the end of the pot was here where the wiper should have been. So how the hell the treble pot worked at all is beyond me, but it did. And I've corrected it and measured it on the scope, and it looks a lot better. In the original video when I measured it with the square wave, with both pots at the center, it looked a bit jagged on the rising edge. Now it's actually looking like a flat square wave when both pots are in the center, which is how it should be. So I'll show that on the oscilloscope when I'm doing the testing with the balance pot in a little bit. I had a 47 nanofarad capacitor here across the base pot, mainly because I don't have a 39. I've now reduced that to 33 nanofarad, so we'll see with a sound test how much that affects the bass, because the bass was a little bit overpronounced, especially at the center. So I've changed that and we'll see how well that works. As for the rest of the circuit, not much has changed. I've just put in the values of what capacitors I'm using in the audio path, in this case 4.7 microfarad. They don't need to be as high as they are in the original circuit because, well, you're not driving a low impedance output like such as a speaker, so you don't really need a high capacitance in this type of discrete circuit. So anyway, without further ado, and I like to always overemphasize that as adieu for no apparent reason, even though adieu means goodbye. So without any further goodbye, no, seriously, without any further ado, I'm going to set the circuit up, change this trim pot out to the 1K, reset the voltage output with 250 millivolt in for 2 volt RMS out with the volume control at full, bass and treble in the center, and then I'll connect the balance pot across the circuit where it needs to go and run some tests. So let's get going. The circuit is back on the desk, powered up. The trim pot has been changed out to the 1K multi-turn pot and adjusted, so we've got a 2 volt RMS output with a 250 millivolt RMS input. As we can see there, it's 2.02 volt RMS, but it's close enough. And we've got a nice sinusoidal waveform there. Okay, so I'm going to bring in my 10K pot. I'm going to use some alligator clip leads for this because it's easier than soldering to the pot. Plus I don't want to solder to the pot unnecessarily if I don't have to, unless it's already been soldered to. So I'll connect the center wiper to ground. And I'll pick my other alligator clip that just fell on the floor. Pot is in the center, roughly. And I will connect that to there. And I will connect it where it goes in the circuit, which is over here. Excellent. So now I'll play with said pot. I'll rotate it fully counterclockwise. No change. Fully clockwise, we get a slight increase in gain. Now that could also be because that 470 ohm resistor, which the clip lead is connected to, is too high. So to eliminate that as a possibility, I'm going to go onto the other side, so basically at the negative point of the capacitor, and then I will vary the pot. As we can see, it just distorts the shit out of it, but there's still no real attenuation. Again, resistors in parallel divide, and the resistance will be always at or lower than the lowest resistance in the circuit. Okay, so that did not work. So just for completeness, I'll change the pot out to a 5K and see if there's any difference there. So off goes the 10K. I'll connect the 5K. Pot is in the center roughly. There we go. So let's rotate this fully counterclockwise. Not much change. Fully clockwise. Again, doing the same thing. So this is not looking that great for having both pots in the circuit at the same time. And finally, I'll change to the 1K pot and see if that makes any difference, but I seriously doubt it. And this is all in the interest of experimentation, and if you follow the basic laws of electronics, this kind of testing is pointless, but anyway. Alright, the pot is in the center, rotate it fully counterclockwise, no change, fully clockwise, not much change. Okay, so that is definitive. For now I'm going to leave the 1K connected, but I'm going to disconnect or remove the 1K trimmer out of circuit. Now immediately we've got quite a significant reduction in gain with the pot at the center. So if I now rotate fully anti-clockwise, not much change. Fully clockwise, very little change. Again, I reckon it's because that 470 ohm resistor is too high. So let me change back to the 10K pot. I don't see any real need to use the 5K in this instance. Okay, it's not looking that great. So fully anti-clockwise, not much change. Fully clockwise, negligible change. So as a balance pot, even if you got that 470 ohm resistors value correct, all it's going to do is when it's fully attenuating one channel, it's not going to give that much reduction in gain, and all it's going to do is increase the gain to the other channel. So the other channel will get louder whilst the attenuated channel will get quieter, and that's not how a balance pot is supposed to work. So I'm going to say that that idea of their original schematic is out, because it just does not perform the way I want it to perform. So what I'll do is I'll go back to my original idea, which is the L-pad attenuator balance control after the volume pot. Now with that in circuit, we can see the gain has dropped off a little bit with the pot in the center, but that is fine. That can be adjusted with that trim pot a little bit up a bit if you wanted to. But if I now rotate fully clockwise in this case, the channel buggers off like it should, and if I rotate from the center to fully counterclockwise, the gain does increase by about 200 millivolts RMS, which is more satisfactory operation, because that's how the balance pot should actually work. If I increase my voltage per division, we can see that, well, it does attenuate right close to the end of the pot, but it's more gradual, and that's how it is supposed to work. So there we go. So I've now changed to the 5K pot, and with it in the center there is a little bit more reduction in gain, but not much. Fully clockwise, yeah, it buggers off. Fully counterclockwise, it increases probably in this case by 300 millivolt. But the overall attenuation is gradual. So I'm probably going to stick to the 10K linear because it seems to function okay. So I've gone back to the 10k potentiometer and I've readjusted the 1k trimmer, so we've got 2 volt RMS out or thereabouts. And what I'm going to do is I'm going to go into square wave mode. Now, as we can see, with both the bass and the treble pots sitting in the center, we have a nice, well, reasonably nice square wave output. As compared to the original one where it was all spiky on the leading edge. So if I now rotate the treble full, there we go, center, no treble, that's what we should be seeing. And the bass, that's full bass, flat, no bass. There we go. And I've got an issue with wiring or something. Something's moved. Oh, the center came out. There we go. I just wanted to show you how long it takes this circuit to stabilize when you first power it up. So I'll turn it off. And now I'll turn it on. See how it's distorting badly? And then the positive gain peak starts to come up slowly, and it takes a while for the voltage to increase to the 2 volt RMS, and it's taking at least 5 to 7 seconds to stabilize. So what that would mean is if you turn this on with an audio source going into it, directly into a speaker, at first power on it's going to sound distorted as anything and then slowly come up to sounding correct. As Julius Sunder Miller would say, why is it so? Well, it'd be because of this 470 microfarad capacitor here in the collector and emitter circuit of the input stage transistors, combined with this variable resistor and the 1K resistor that's coming from the collector of the PNP transistor to the positive terminal of that capacitor. It's kind of acting like an RC delay, because I'll just demonstrate something. I'll remove the capacitor out of circuit. Yeah, the gain buggered off, but that's fine, so I'll increase that so we can see stuff. We've only got like 330 millivolt coming out, but turn it off and then wait for it to discharge. There it goes. Turn it on. There's still a slight distortion rise and then comes into conduction correctly. Not 100% sure what else is causing that. Maybe it's the DC bypassing over here with the 1K resistor and 100 microfarad capacitor at the input stage. I could try bypassing the 1K resistor. If I can find a wire just knocking about on my desk to insert in the breadboard. Here's one. Nice, here's one I prepared earlier. So I'll just go from the positive, if I can get it in there. Alright, don't go in there then, I'll go in there then. Right, and I will put it on the other side of that resistor. There we go. So that's completely bypassed now. So we turn it off and wait for it to discharge. There we go, turn on. Right, there's still a slow rise there, so it has nothing to do with that DC decoupling circuit acting as an RC network. So I'll remove that wire. So I could try substituting the value of the capacitance. I don't know why it's 470 microfarad. I'll stick a 33 microfarad in place of it. In the right holes would be good. And then drop that down. And as we can see, we still have roughly the same voltage output, maybe a few millivolt less, but it still seems to be amplifying correctly. So if I turn that off, wait for it to discharge. and then turn it on, see, we still have that distortion and slow rise, so it's got nothing to do with that capacitor. So I'm not 100% sure what's going on there. Maybe someone can analyze the circuit and give me ideas, but for it to stabilize after 7 seconds seems like a long time. So I'll take that 33 microfarad out and I'll put the original 470 back in, because, well, it seems to work. Why change it? There we go. I mean, the value of the capacitance might be to do with the setting the gain structure, bypassing of the 1K resistor properly. What's next with this? Well, what I'm going to do is I'm going to hook the power amplifier back up to it, and the speaker and an audio source. We're going to do a sound test for it. Going to test the operation of this balance pot, maybe swap some pots around in the process, and now test the tone control networks with the treble pot wired correctly and the capacitor for the bass pot reduced, and just see how it sounds. So let me get that set up and we'll come back in just a moment. Okay, we're all connected up, and there's a bit of noise because of all the exposed wires. So let's play a track. Alright, let's play with the balance. Treble. That's a lot better. That's how it should operate. Bass. Okay, that does seem to be functioning okay, even though the bass seems to be distorting a little bit. Not 100% sure why that is. Maybe, could be maybe the circuit or the speaker itself. I tried messing around with the value of this balance pot during the test. I changed it back to the 5K, and I did find that the operation of the pot was a little bit smoother at 5K than 10K, but as I say, I think I'm going to leave it at 10K. Other than that, the circuit seems to be performing the same as it did before. The treble works a lot better when it's actually wired correctly. Funny that. So yeah, it's not the best amplifier circuit in the world, but it does actually work. But their original balance control doesn't. It shouldn't be making the other channel like twice or 3 times as loud whilst you're rotating the pot. So whoever came up with that idea is, in my opinion, a wanker. However, that's how the circuit is going to be wired now, with a typical L-pad attenuator as a balance control after the volume pot. It's just the standard way it's done anyway, and seems to make the most sense. Next thing to this is, as I said in the previous video, is routing a PCB. Now, that's going to be a challenge for me because, well, the preamp, power amps and power supply are all going to be on the same board. Secondly, it's going to be single-sided. Now, there's a reason for that, because I want to make this like a novice project. Well, not a novice project, but a intermediate person's electronics knowledge type project, where they have some basic understanding of soldering skills and circuits and stuff. But I want to make it easy on them if you have to repair the circuit, or you've put parts in the wrong place and have to remove them and change them around. A double-sided plated through-hole PCB is a bastard to desolder components on at the best of times. So it's a lot easier having a single-sided circuit board in that instance. So as for where the balance pot is going to go, I'm simply just going to add in a 1K resistor, and I'm going to put in my balance pot like that, and ground it. And when you rotate this pot fully clockwise, the left should be attenuated and the right should be the one coming out the speaker, so the clockwise position is there. And that's exactly how it's going to be done on the PCB. Anyway, I'm going to leave this video here, and I hope you enjoyed it. I enjoyed making it because I love experimenting with circuits. Building a circuit, it does work, yes. Let's see what we can do to modify it to make it better. Well, in this case it was modified to actually make it work, because the balance pot does not work. It will work with this pot removed and the value of this resistance dropped, and maybe this pot being 1K as in the original pot here. But you don't really want, when you rotate the pot fully clockwise or anti-clockwise for either channel, this going higher than 2 volt RMS out. So you'd have to choose a fixed resistor value for here that sort of like sets the minimum resistance that this capacitor sees to ground, as if this trim pot was in circuit preset. So whatever the value of this trim pot is set to would be the value of your fixed resistor here. So even with the circuit powered, I want to see what sort of resistance our pot actually is at. About 84 ohms. So you would take the next value of that, which I'm going to say, well, I think you can actually get an 82 ohm in half watt 1% metal film, but failing that, you'd probably set it to something like 100 ohm. So anyway, that's going to be it for this video. Hope you enjoyed it. Leave your comments and thoughts below, and if you haven't subscribed, please consider doing that as well. And as always, this is the Austereo saying, see ya, have a great day. I'll see you in the next video.